Alright, hello everybody. Today we're going to talk about arithmetic sequences, and we're going to talk about, first of all, what they are, and how we can find the nth term and other variables. So to start off, I'm going to show you a problem. So, an amphitheater has seating that fans outward such that the number of seats in the following rows increase by 4. If the first row has 12 seats, how many seats will the 26th row have? Now, the initial response in a lot of people would be to start adding 4 seats about 26 times. But I'm here to tell you that there is a much faster and much easier way to do that. So, let's continue on. So, a sequence is defined as an ordered list of numbers, and specifically an arithmetic sequence is a pattern of numbers that is characterized by the addition or subtraction of a constant term. So that's what it is. So now we're going to look at a couple of different strands of numbers and try to determine if they're arithmetic or not. So this first one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, yes! That is an arithmetic sequence because it increases by a factor of 1 each time. This next one, -4, -3.3, -2.6, -1.9. Yes, it is indeed an arithmetic sequence because it decreases by a factor of -0.7. Now, a lot of times people wouldn't necessarily recognize that right off the bat. So, if you're ever trying to determine if something is an arithmetic sequence, you should always, just use your handy-dandy calculator. It won't hurt you, just to make sure that it is or isn't. This next one, 1, 3, 8, 10, 14. No, that's not an arithmetic sequence because the term by which it changes is not constant. It's +2, +5, +2, +4. It's just, nope. This next one, 10, 5, 0, -5, -10. Yes, it is an arithmetic sequence because it decreases by a factor of -5. So it's important that you make sure you know whether you're subtracting or adding in terms of creating your D, which we're going to talk about in a sec, which is the factor by which it changes. And then lastly, we have 4, 8, 16, 32, and 64. Now, a lot of people will recognize that, yes, this is a list of numbers that has a pattern. It's multiplying by 2 each time, right? Well, yes, but it's not an arithmetic sequence. This is actually a geometric sequence. And there's another way of solving those kinds of problems, but that's with a different formula, and that's just for a different video. Not here with our dear arithmetic sequences. Okay. So some important terminology you need to know whenever you're solving these is, first of all, n, and that's the number you're looking for. U1, which is just the first term in the sequence. And as I was talking about earlier, D, which is the rate of change, also known as the number that you were adding or subtracting by. So here is our lovely formula for arithmetic sequences. In my class, we call it unit, just because all of our formulas get to have funky names to help us remember them. So if you want to just call it the arithmetic sequence formula, fine, call it that, but I'm going to keep calling it unit, so that's what I'm talking about when I say that. Alright, so now that we know all of our important stuff, like what an arithmetic sequence is, and the different little symbols within the formula, we're going to take a problem and break it down and solve it. So for our first one, if U1 equals 12 in an arithmetic sequence, and 3 is subtracted to each term in the sequence, what does U14 equal? First of all, we gotta make sure we have our nice little unit formula right here. And now we can take this problem and break it down. So it tells us right off the bat, U1 equals 12, okay? It says 3 is subtracted each term, and that means our D is -3 because it's subtracted 3 times each. Very simple, right? And then lastly, this is kind of the one that tricks some people up. Our N is 14 because U of N, or U of 14, is what we're looking for. So whenever we're plugging in anywhere in this formula, we're going to put in 14. So we start by plugging in all of our little terms into our unit formula. So we have U14 equals 12 plus parentheses 14 minus 1 parentheses times -3. So start by subtracting 1 from 14. You take that, multiply it by -3, and add 12, and voila, U14 equals -27. It's that easy. It's that fast, and it's great. It's a great tool to have. So, I'm going to move on to another practice problem. So, in an arithmetic sequence, if U37 equals 224, and 4 is added to each number in the sequence, what is U1? So for this one, we already have U of n. It tells us that U37 equals 224, excuse me. So we're not looking for that. Instead, we're looking for U of 1. And this is really easy to do. It's the same idea. You just have to, break it down and plug in all of these numbers. So we start, and we have our n, U37, so 37 is n. D, which is 4, because 4 is added to each number in the sequence. And we don't know what U1 is. So when we're first starting this, instead of putting in U of 37, we're going to put in 224, because it tells us that's what that equals. Then we're going to put U1 in as our variable, because, of course, we don't know that. And then we're going to plug in plus parentheses 37 minus 1 parentheses times 4. We're going to do some simple math. 37 minus 1, 36, times 4, 144. And then do some basic algebra, subtract 144 from both sides. And bang bang, you have U1 equals 80. It's a really simple concept, so I hope this is helping. And now if we look back to our original problem that is not so big, bad, and scary, of the amphitheater, we can break it down. So the rows increased by 4, so that makes D, the rate of change, equal to 4. If the first row has 12 seats, well, the first row is going to be our first term, and that means our first term equals 12. And how many seats will the 26th row have? Well, n is going to equal 26 because that's the number we're looking for. So you simply plug all of those in to unit U26 equals 12 plus parentheses 26 minus 1 parentheses times 4. And you get 112 seats in the 26th row. So that's how we do all of that. I hope this video is helpful. And to end, I've got to have, a nice cat at the end because signature. So I hope this video didn't make you cry. In fact, I hope that it helped you to stop crying if you were crying over arithmetic sequences. Alright, see you next time.